Kia ora. Here's our second example. Again, what you do is you go to the molecular ion and you look for patterns, and hopefully you can see there's no nitrogen, chlorine, or bromine because of the even number and lack of the isotopic peaks. That little peak down there is the carbon-13 isotopic peak, which is 1 unit higher in a 60-to-1 ratio. Now, we've got to support that evidence from others, so there are no strong signals over here in the fingerprint region, and there are no peaks here above 3,000, around about 3,500, where we would expect the NH peaks. And there's also no peaks in the carbon NMR, where we would expect to find a carbon atom bonded to a nitrogen, although I do agree there's something on either side. We know there are alkyls, and that's supported over there, so make sure you match those two up. And we can very clearly see that there are no carbon-carbon double bonds because there's no narrow, thin peaks over here, medium size, and no medium-sized, narrow peak for the hydrogen attached to a carbon-carbon double bond. We do have a carbonyl peak, and we see that over here, but we can clearly see that it is not a carboxylic acid because I don't have that broad strong absorption peak between 3,500 and 2,500 centimeters to the -1. And we know that it can't be an aldehyde or ketone because I don't have peaks that, the peak is too upfield. These peaks are around about 200 and further down. So although this is in the right region in the IR for an ester carbonyl or aldehyde, ketone or aldehyde, we can cross out the ketone and we can cross out the aldehyde. We know it's not an acyl chloride because it's too low. Acyl chloride's around about 1,800, and we know it's not an amide because it's too high. Amide's around about 1,650, and of course we know it's not an amide because of that. Other supporting evidence is we do have some strong peaks where we would expect to find the carbon-oxygen single bond stretch. So what we've probably got is an ester, because here we can again see a carbon-oxygen single bond stretch. A carbon that is probably bonded to an oxygen, and this is probably a carbon that's bonded onto a carbonyl. So if we take our molecular ion and we say, right, I've got 2 oxygens present, and I subtract that value, I get 84, I divide it by the molar mass, and I get 7 exactly. But I do need hydrogens, so I don't have 7 carbon atoms, I have 6, with the other 12 mass being from the hydrogen. And this gives me a CnH2n general formula, which matches an unsaturation of 1 because that is due to this double bond from the carbonyl. Kia ora.